All right, let's dive into the hidden world that keeps our entire modern life running: industrial pump standards. Now, I know that sounds super technical, but trust me, knowing the difference between ANSI, API, and ISO can mean the difference between a facility that runs like clockwork and one that's a costly or even dangerous disaster waiting to happen.
So let me just start by asking you a question. What do you think is the most important machine that you have probably never, ever stopped to think about? It's not your computer, it's not your car, it's something way more fundamental, working 24/7, completely behind the scenes of almost everything you do.
You're looking at it. It's the industrial centrifugal pump. This is the true unsung hero of our world. I mean it. These machines are literally the heart of our infrastructure. They move the fluids that give us clean water, cool our buildings, and power our refineries.
And that's exactly why this is so important. Because when one of these pumps fails, the consequences can be massive. We're not just talking about losing money from downtime, we're talking about serious safety hazards, environmental spills. The stakes are just incredibly high.
So that brings us to our first section. To manage these kinds of high-stakes situations, the entire industry has to rely on a critical set of rules, and this is where standards come into play.
So what even is a pump standard? Well, think of it like a rule book. It's a very specific set of guidelines that lays out the minimum requirements for everything: the design, the materials used, the testing it has to pass. Its entire purpose is to guarantee a baseline of quality, reliability, and, of course, safety.
Okay, let's meet our first contender. This is the standard you're going to find in the vast majority of general industrial settings, especially in North America. Let's talk about ANSI, the versatile workhorse.
So ANSI stands for the American National Standards Institute, and its claim to fame, its killer feature, especially under the well-known B73.1 spec, is something called dimensional interchangeability. And believe me, for anyone running a facility, that is a huge deal.
So where would you actually see an ANSI pump in action? Well, think moderate-duty applications. We're talking about the pumps that keep our water clean, our buildings cool, and our food processed safely. They're the perfect fit for jobs where the conditions aren't too extreme.
And this is the magic of it. Because of that interchangeability, you can literally pull out a pump from one manufacturer and drop in a pump from a totally different one, and it will fit right into the same spot. No need to change the pipes, no need to change the base. That saves a mind-boggling amount of time and money.
Now, if ANSI is the versatile workhorse, then API is the heavy-duty guardian. This one is built for the absolute toughest, most critical jobs on the planet.
API is the American Petroleum Institute, and its famous standard, API 610, is all about one thing: maximum, uncompromising reliability. These pumps are engineered from the ground up to operate in the most demanding, most hazardous environments, where failure is simply not an option.
So how do they do that? Well, it all comes down to a philosophy of just over-engineering everything. We're talking much thicker casings to handle extreme pressures, way more robust mechanical seals to prevent dangerous leaks, superior materials, and they go through a whole battery of intense tests that have to be documented down to the last nut and bolt.
So the API promise is this: it's built to run for years without major issues, and if it does eventually fail, it's designed to do so in a predictable and safe way. It's all about unmatched durability when everything is on the line.
Okay, so what if your operations are spread all across the globe? Well, that's where our third and final standard steps in. Let's talk about ISO, the global standard.
ISO is the International Organization for Standardization. Its main goal isn't just raw performance, it's global compatibility. By using metric dimensions and internationally recognized specifications, it basically creates a universal design language for pumps, no matter where you are in the world. This makes ISO the no-brainer choice for multinational companies. If you're building a new plant in Europe or you're sourcing parts from Asia, sticking to ISO standards just ensures that everything is going to fit together perfectly, regardless of where it was made.
And that is the real beauty of ISO. It's all about consistency. You get one standard, one design language, and one set of expectations for all your operations. It just simplifies engineering, purchasing, and maintenance on a global scale.
Okay, so we've met the three main players. Now, for the fun part, let's put them side by side in a head-to-head comparison so you can really see the trade-offs.
The first thing you'll probably notice is the sticker price. An ANSI pump is going to be your most economical option by far. ISO pumps are usually somewhere in the middle, and then you have API pumps. With all their heavy-duty features and exhaustive testing, yeah, they command a pretty significant premium.
But hold on, That's just the initial price tag. The smarter question to ask, the one that really matters, is this. What about the total cost over the pump's entire lifetime? This is where the story gets much, much more interesting.
This is where you see how their philosophies really differ. ANSI's goal is interchangeability, making it a fantastic value for moderate, everyday services. API's goal is maximum reliability, which, yeah, it's more expensive up front, but it often delivers a lower total cost in critical applications because you have less downtime and fewer repairs. And ISO? It strikes a balance, offering that global compatibility with performance that you can often spec up to be nearly as robust as API.
So, with all this information, how do you actually make the right choice? This final section is your pump buying playbook, a clear path to making the right decision for your needs.
It really just boils down to these 3 simple steps. First, analyze your operating conditions. What's the pressure, the temperature, the fluid you're pumping? Second, assess the criticality. Be really honest about what the consequences of a failure would be. And third, consider your geography. Do you need that local interchangeability, or do you need global compatibility?
And here are the big mistakes to avoid. The most common one is over-specifying, buying a fortress of a pump for a simple water circulation job. It's just a waste of money. The flip side is even worse, under-specifying for a critical, high-pressure service. That's a recipe for disaster. And finally, never ignore material compatibility. The wrong metal can corrode and fail in no time, no matter which standard you choose.
Ultimately, the most important takeaway is this. There is no single best standard. There is only the standard that is best for your specific job. So the next time you turn on a tap or flip a light switch, take a moment to think about the incredible, standardized machines working in the background. And it makes you wonder, right? What other hidden standards are out there quietly keeping your entire world running?